Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Namo Buddhaya. Hello everyone, welcome back to my YouTube channel. In this video, I would like to presentation about polymeric materials. And my lecturer is Professor Dr. Tjokorda Tirta Nindhia, Sarjana Teknik, Magister Teknik. Before we start the presentation, let me introduce myself. My name is Inyaman Satridan Macayadi with name 220-553-1159. I'm from Udayana University, take engineering faculty with mechanical engineering department. The literature sources that I use the most on this presentation is electronic book, Science of Engineering Materials, Volume 2, Materials by Manas Chanda. Table of content that we want to discuss on this presentation are 4.4 molecular weight of polymer, 4.5 definition of resin and plastic, 4.6 polymerization processes, 4.7 structural shape of polymer molecules. 4.4 molecular weight of polymers. Molecular weight of polymers can be classified into three, namely number average molecular weight average molecular weight, and viscosity average molecular weight. First, number average molecular weight. Number average molecular weight is a polymer sample weight per mole. All molecules in the polymer are considered to have the same weight. So, this is the number average molecular weight formula. Next, weight average molecular weight. Weight average molecular weight is the weight of the polymer sample of its existing molecular species, calculate based on the mass and polarizability of existing polymer species. Large mass polymer contribute greatly to the measurement. Measurement method is light scattering. This is the weight average molecular weight formula. For example, a polymer sample consists of 3 grams with a molecular weight of 20,000 and 2 grams with a molecular weight of 70,000. Count A. Number average molecular weight or Mn, B. Weight average molecular weight or MW. So this is the solution of the example. This is the A and this is the B. Based on the solution, we got Mn is equal to 40,000 and MW equal to 55. And fun fact from the example, the value of MW is always greater than Mn because of the difference in the method used to measurement molecular weight. If MW equal to Mn, all molecules have a measurement the same molecule, called monodispersion. In this system, the weight of each molecule dispersed or spread in the system in the same. If MW bigger than Mn, then the system is called polydispersion. Polydispersion index is MW division to Mn ratio. Last, viscosity average molecular weight or MV. The viscosity average molecular weight is defined by the equation. This is the formula of viscosity average molecular weight. And for A equal to 1, so MV equal to MW. Then for A equal to -1, then MV equal to Mn. 4.5 definition of resin and plastic. Definition resin and plastic. So the left picture is resin and the right picture is plastic. What is resin? Material science of polymeric chemistry defines resin as a highly viscous and solid substance obtained from synthetic origin or plant. It has the property of being convertible into polymers. It is also used as the supplement for most of the plastic-based substances. As compared to the plastic, resin is less consistent, volatile, and among other things, of terpene. The common example of resin are balsam, Canada balsam, ball of Gilead, and several other those three that belong to the family of Dipterocarpaceae. Resin has long history since ancient age, where it was being treated as prized substance and was given a religious value as well. From a chemical point of view, it can be categorized into a group semi-solid and solid are most common. And what is plastic? According to material sciences, plastic is a substance that can be molded into different forms. These are kind of organic polymers containing high molecular mass. Most of the types of plastic are obtained as derivative product from petrochemicals, while there are many that are made from renewable materials like cellulose from cotton, then cotton linters, or polylactic acid from corn. Today, these are being used as a replacement of most of the products because of being low-cost products. Versatility, ease of manufacture, and the quality of getting molded in the several forms. And in the modern era, it has continuously replaced several other traditional materials like stone, horn, wood, leather, glasses, and much more. Explore resin plastic. So this is the epoxy resin plastic. First, we need to explore that plastic actually is. While plastic are made from the carbon, things such as oil and gas. That's why many plastics are called polysomething. Although that isn't the case with epoxy because it contains an epoxy ring, which gave this unique wonder its name. Taking a look at epoxy molecular structure. F4 epoxy is an epoxy resin, and there are thermoplastic and thermosets. Thermoplastic are the type of plastic that your milk jug is made out of. Thermosets. Then thermosets are some mixed-cell reaction. If you put the flour, sugar, and egg into the mixture, but once that is mixed, there is not getting those ingredients back out. This ring leaves the molecule structure open to all different kinds of semicell formation, but all the base of these molecules. And we move to thermoplastic versus thermoset. So thermoplastic made with heated up and then molded to whatever you want and let cool and shrink or harden. Thermoplastic are the polymer we can rather easily recycle. So basically, thermoplastic can be recycled through the following process. And then thermostat, not possible to recycle or reshape the polymer. Thermostat polymer, we heat it up and cured and now useless. Thermostats are great at holding their shape and strength when they're heated. Then, if thermoplastic becomes soft and easily lose their shape. When creating a thermoset object, you only get one chance to get the shape right. So this is the differences if we recycle thermoplastic and thermoset. So from the video, the differences of resin and plastic is basic of this distinction, the definition. Resin, an inflammable organic substance that is insoluble in water and is obtained from trees and other plants, which plastic is an atrophical material derived from various organic polymers like nylon, PVC, polyethylene, or etc. From durability, resin is less durable than plastic is more durable. From the meltability, resin has no meltability, then plastic have the meltability. From durability, resin doesn't have the durability which plastic have the durability. From environmental issue, resin has no, but plastic has the environmental issue. 4.6 Polymerization processes. Polymerization processes can be classified into two: addition polymerization or chain growth and condensation polymerization. So we're gonna make addition polymers with alkane. Alkane is made from monomers. This is the carbon-carbon double bond and an alkane 18. The double bond we call alkane are unsaturated. Double bond can break into the single bond, which allow the carbons to form the new bonds. If we have 3 ethane molecules, we open up so we can reach each other, and we have one long chain as a polymer. This is the reaction of that. We have monomers on the left and we have a long chain polymer on the right. This reaction sometimes involves hundreds of monomers. And we move into the condensation polymerization. Condensation polymers. conditioned polymers made of ester link. For example, condensation polymers made from two different monomers, a dicarboxylic acid monomer and a diol monomer, which contain two alcohol. This is representation of the rest of the molecule. And we want combine, then we made water molecule or H2O. And the bonding was start. And if they're bonding, we call it ester link. At the moment, this is all dimer and because of only two monomers. We need to remove we put the empty bond into the outside. And the finish, we add this. So that's it about the condensation processes. We move into 4.7, structural shape of polymer molecules. Polymer are compounds whose molecules have high molecular masses and composed of a large number of repeating units of individual structure. Polymer we can be classified into two. First, naturally occurring polymer. Example, protein, starches, and cellulose. And second, synthetic polymers. Example is plastic. And the classification of polymer can be classified into this. But we want to discuss classification of polymer by the structural shape. So this is the structural shape of polymer molecules. We can classify it into three. First, the linear shape. Second, the branches shape. And the third, the cross-link shape. Linear polymer resembles spaghetti with long chains. The long chains are typically held together by the weaker van der Waals or hydrogen bonding. Since these bonding types are relatively easy to break with heat, linear polymers are typically thermoplastic. Branches polymer resemble linear polymers with the addition of shorter chains hanging from the spaghetti backbone, since these shorter chains can interfere with efficient packing of the polymer. Branches polymer tend to be less dense than similar linear polymers. Cross-link polymers resemble leather. the chain link from the one backbone to another. So unlike linear polymer, which are held together by weaker van der Waals forces, cross-linked polymer are tied together via covalent bonding. So that's all about the polymeric materials. Thank you for watching. Bye.